Hello, welcome to this video. Today we're going to do this problem. So let P, Q, and R be positive primes and N be a positive integer such that P plus N over QR, Q plus N over PR, and R plus N over PQ are whole numbers. Show that P is equal to Q, which is equal to R. So first of all, what we're going to do is to look at this in the modular language. So this is the same as saying P plus N is congruent to 0 mod QR, Q plus N is congruent to 0 mod PR, and R mod N is R plus N is congruent to 0 mod PQ. Now we can multiply this and this by the same number, and this congruency of 0 will still be true. Right? So if I multiply, say, this by 2, so 2 times P plus N is also going to be 0 mod 2QR. So what I want to do is to here multiply by P, here by Q, and here by R. Why? Well, because now I'll get PQR here, PQR here, PQR here, but I'll get 3 different numbers here. So maybe I'll be able to play with those numbers in some way that will lead me to the solution. So from here I can get that P times P plus N, which is P squared plus Pn, and similarly Q squared plus Qn. So this is after multiplying by P, this is after multiplying by Q, and after multiplying by R. R squared plus Rn. All 3 of them are 0 mod PQR. So now we know that if two numbers are 0 mod the same number, then their difference is also obviously 0 mod that number. So if I say do this minus this will still be 0 mod PQR. So I get P squared minus Q squared plus Pn minus Qn is congruent to 0 mod PQR. Now I can put these together, right? So here I have N times P minus Q. Here I have P minus Q times P plus Q. Then I can put out P minus Q in the front, and I'll have left P plus Q from this and plus N from this. This is as P plus Q plus N. This is congruent to 0 mod PQR. So now I'm going to, since everything here is symmetric, right, in any one of these I can flip wherever I want, any 2 or any 3 I want, or I can do whatever, and I'll still end up with one of these again. This is symmetric, meaning that I can assume a maximum term in the middle and the minimum. So I'm going to pick R bigger than or equal to P and bigger than or equal to Q. Why? Well, I know if this is 0 mod PQR, it means PQR divides this number, meaning that R also has to divide this number. So R divides into P minus Q, times P plus Q plus N. But R can't possibly divide into P minus Q, since P minus Q, this is at most P minus 2, smaller or equal to P minus 2, and that is strictly less than R. So if this is strictly less than R, then R can't possibly divide this number, right? Unless that number is 0. Well, let's actually assume that P is not equal to Q. So in this case where p is not equal to q, r cannot divide this number, so it has to divide p plus q plus n. So r divides p plus q plus n. So so we know r divides p plus n, right? Because qr divides p plus n. So r divides p plus n. So again, if these two are divisible by the same number, then their difference is also divisible by the same number. So r is divisible by q, but these are both prime numbers, right? And also I should have mentioned, because r is a prime number, it had to divide either this number or this number, and because it couldn't divide p minus q, it had to divide p plus q plus n. Also should have mentioned that. But now, since r and q are both primes, if r divides to q, that just means r is equal to q. But similarly, we also know r divides into q plus n, which would mean that similarly, by the difference, r is equal to p. So we got r is equal to p is equal to q, but we're not actually done because that is a contradiction to what we assumed. So p actually is equal to q. So we know it has to be the case that p is equal to q. Now let's look back at these three. So if I plug it into here, I get p plus n. Alright, the pr divides into p plus n. And this is the same, right? Because q is equal to p, then p plus n divides into p plus n is divisible by pr, so it's the same. But here we get the p squared, right? So this is pq, p squared divides into r plus n. So now we know that p divides both of these numbers, right? P divides pr, p divides p squared. So p divides p plus n, it's p divides r plus n. But if p divides p plus n, that means that p divides n. But now, since p divides r plus n, since n is divisible by p, we know that p is divisible by r. P divides into r. As p divides into r plus n, so p divides into r. And again, since they're both prime numbers, we get that p is equal to r. And we know that p is equal to q, so finally we get p is equal to q, which is equal to r. And that's it. If you want more content like this, please subscribe to my channel. I'll upload more interesting content and things like this in the future. And finally, that's it.